Hello and welcome to this new video. Today I would like to discuss a just recent introduced command in SOFiSTiK version 2020. It is the combination tracing command. And as it is a combination tracing command, we need a couple of combinations to test this feature. And therefore I'm going to use one of the SOFiSTiK online tutorials. And the reason why I picked this example is simple. Because we have a huge number of load cases and combinations already available. So let's get into it. First of all, what we need to do is we need to insert a text task to our project. So yes, you hear it correctly, this command is only available in the text input. However, the input is straightforward, so it shouldn't be a reason for you not to test this feature. Well, I have inserted a new task. I renamed it to Load Tracer. So I will open this task now by using my right mouse and I use Edit. Now I'm here in the text input. For those not familiar with the text input, you don't need to be worried about. It's just a couple of lines you need to enter and this is something everyone can do. So here in front of me, I do have two parts. So what I will do, I will focus on the quad element. So I will trace results for a specific combination of a specific quad element. So I will not show this here for any other elements. However, you see here in the bottom, I did it also for a beam element, for instance. Let's look into the input itself. First of all, we need to call the program module maxima. To start now using this command, we need to enter in the first line +proc maxima. In the second line, we enter the head information. So we enter head and the headline we want to consider in our reports. And then we are already there to enter our tracing command. But before we do that, to close actually our program module maxima, we also need to insert an AND at the end of our input. So now let's get into the load tracing command itself. There are only a couple of things you need to enter, and if you, again, not familiar with the text input, there is an easy way to get an idea what you need to enter into this command. So what I do is I click here on the load tracing command and I hit F1. And by doing that, the interactive user manual opens here on the right hand side. And this user manual jumps straight away into this input command. We see it here, trace, and gives me all the possible items, so basically the possibilities for this command. What is now required for you to enter? First of all, the load case number you want to trace. Of course, this should be the result of a combination. In my case, it's the result of a ULS combination. Then the next input is the type of the element you want to trace. In my case, it's a quad element. There are a couple of elements available and you see it also here in the user manual on the right. Furthermore, we need to have an element number. I picked here 10,339. So this is not any random number. This is an element somewhere on my top slab of the bridge. Then the last input we need to enter for the quad elements is the option command. So basically how the tracing should work. There are only two options available. One option is that the program shall trace also intermediate superposition, and also there's an option to kind of filter out input load cases which haven't contributed to the superpositioning. So I will start here with the option F. So without further ado, let's go ahead and calculate this input. So what I do is I simply right click on the task and calculate this load tracing task. Okay, the calculation didn't take that long, so let's see what we have available now in our output. So I use the right click again and I open the report. Now I'm here in SOFiSTiK report browser and I see straight away my two tables the program generates for me. And what I see straight away, I see my quad element number 10,339. I see a list of all the load cases and their description. I got a factor also and also the MXX value. So you might ask now, why MXX? Well, the combination load case I have used, 2101, is actually the combination result for the bending moment MXX for quad elements. Okay, Then we have a second table because I did it also for the load case number 2102. We see there's a little bit of a difference of the load cases which have contributed to the total result. Let's stick with the first table over here, the one which gives us those two warnings. Well, two of those load cases, 412 and 907, are actually already some intermediate combinations. So that means that there are already other load cases combined to actually get these results for load case 412 and 907. So I will now show you how we can look into this intermediate combination to get actually the single load cases out of it. And therefore we need to go back to SOFiSTiK Structural Desktop and we need to look into our text input. So what I do is I simply add another option over here. I use I for tracing also intermediate combinations, and I can run the task straight away. By doing that, the database gets updated as you're familiar with, and I can open the report straight away. And now you see instead of those load cases 412 and 907, we already got the single load cases. So we have now actually traced back our results to the original single load case. Here in this example, it's the load case 121, 503 and 563. And that's it actually what you can do with this load tracing command. What we now do is we dive into these warnings popping up here below the first table. And therefore, I will bring up a graphic to give you first of all an idea about the different load combinations and the single load cases. So let me quickly open this diagram. And as you remember, we had the load case number 412 popping up. So let's focus on this one first of all. The load case 412 can be found actually here in the envelope results of the gr_t action. And the contributing load cases are actually the single load positions of the tandem system depending on the lane they have been assigned to. So what the load tracer now is doing, it finds the combination results of this intermediate result. So we had 412, and then it traces inside this combination, or sorry, this intermediate combinations to actually find the explicit load position which causes actually this result. And similar thing actually is here for the load cases 907 and 607, which are part of the gr_u actions. But let's now really look what we have in our example and really dive into the detail. Let me bring up quickly our report so we can note down our load cases. We have here load case 412, 907 and 607. Okay, so the first step I'm going to do, I will add those load cases to trace them basically. And therefore I head back to my input, SOFiSTiK Structural Desktop, the load tracer task, and I will simply copy one of those input lines over here, and I just need to change the load case here to 412. I use F8 to duplicate the input line, and then I enter 607 and also 907. Okay, the next step is easy, simply calculate this input. And what I will receive now is what single load cases have been assigned to which of these intermediate combinations. Let's open the report again and see what we got. And we see it straight away here in the first table. It gives me the load case number 412 and also the contributing single load case, which is 121 and was caused, as we see here in the description, from the tandem system. Then we got load case 607, and this load case contributes single load case 503 and 563. And similar actually happens for the next load case, and this is 907. The reason therefore is because the load case combination 907 actually includes this load case 607. Let me bring up this graphic again to explain it a little bit more in detail. So we have here our intermediate combinations of the UDL loads, and we see that load case 607 is an intermediate combination over here, and it contributes to my load combination results 901 to 916, and we had 907. So that's the reason why we got the similar load cases here in the output. So let's head back to our output again. So to make it a little bit more clear, just in this case, what I will do is I will remove the tracing of the intermediate combinations here for this load case 907. And this can be done in SOFiSTiK Structural Desktop. So I head back into my text input and I remove this option over here. And I confirm the calculation. Here we go. And I open the report again. Cool. So now we see that this load combination 907 includes this intermediate combination again 607. So you see you can really trace back these different levels of intermediate combinations quite nicely with switching between those options available in the command. But there is more to this warning, so let's scroll down to bring it into the center of the screen. And so basically we have now discussed the first part of this warning. So about this intermediate combination numbers. And now let's have a look what this means, this using incompatible SUPP extreme or tie parameter. So therefore I better explain it in the graphic again. So let's bring this up. And I will bring here basically this graphic of the ULS fundamental combination in the center. So my original load combination I have traced was this load case 2101. And by definition of the superposition, the result shall be a maximum MXX result. Okay, so now that we know that we are looking into a max MXX result, so the bending moment in the local X direction of the quad element, we can now double check the results in the report the program spit out for us. Okay, here in the report what we see is we have here the load case number 2101, so we know this is a maximum MXX. And basically this warning gives you the information that the load cases which have been listed above from the load tracing command might have not been extracted from a result of an intermediate combination which was explicitly assigned to an MXX result. And the easiest way to explain this is to look into the result viewer and double check those results. So what I'm going to do is the following. I will now list all the results of my intermediate combination which created those load cases starting from 401 to 416. And therefore I go back to SOFiSTiK Structural Desktop. And here in SOFiSTiK Structural Desktop I have already prepared this. If you're not familiar with the result viewer, what you can do is you right click here, insert a new task, and you scroll down to the section post-processing and then insert this task called interactive list and graphics. So I've done this already, so I simply open that one here and it gives me a list of all those results I have asked for, and this is the load case series 401 to 416. I will bring up the graphic again so you can see what results those are, and those are the envelope results here of my tandem system and which are stored in the action gr_t. So I will go back to result viewer again, and we see now the results of the different load cases. We have the same element number as we traced earlier, and we got here the MXX result. And when Maxima actually generates those envelopes, what it does, it looks actually for the maximum value for this specific force, in that case mxx. And we see here we got in the load case 401, this was already a 6.05 value. And when I go further down, I find this value again here for this load case 407. And when I go further down, I find it a third time. And this is in load case 412. So basically, the Maxima program module goes through all those single load cases and saves then the maximum of the bending moment, and also saves the information of this load case which has caused the maximum the last time. So in this specific example, actually this maximum of the bending moment mxx for the quad element is or pops up actually in 3 different load positions of my example. And the program Maxima just saves the last load case which causes this maximum value for the very last time. And that's actually the reason why the program doesn't give me here, instead of 412, which is assigned to a result of the minimum shear force in y direction, and it doesn't give me here this load case 401. However, that doesn't mean that the list, or basically the results here in the list, are wrong. So that's absolutely not true. So basically the results are completely correct. However, the load position might not be that accurate. This is basically no problem if you just double check the results of the combination with the load combination tracing command. But I recommend to have an eye open for this warning when you are intent to create a specific load situation of your project based on the generated list here from the load tracing command. That's it actually what I wanted to show in this video. If you want to read more about this command, you will find a link to the blog post in the description, where you also can find the download link to this example I have shown today. Thanks for watching this video, and don't forget there is more content about SOFiSTiK FEA on my website. You will find the link in the description below. With that said, I wish you a great day and stay safe.